are now given, let's say sine theta is let's say given to us as 0.7 and we have to find this angle theta. So then can we recall that we have to solve this angle theta using our calculators now. So we know this since that for finding the angle from the trigonometric ratio, we know the logic of sine inverse now. So theta would be sine inverse of this 0.7 which we have on our calculator. So for that I am simply going to use the sine inverse thing by applying the second function logic. So it would be sine inverse of 0.7 which gives me the answer as 44.42. So it would be 44.42 degrees. So we know how to apply sine inverse, cos inverse or tan inverse using our calculator. We are able to now find these angles as well. So this is something which we have already done. So the new thing is this, that there is a possibility that now the examiner let's say gives us secant theta as 1.5. So if now secant theta is given to us, so interestingly the calculators normally don't have the secant, cosecant or cot function. They have only the sine, cos or tan functions. But since if the secant theta is given to us, so I can easily find cos theta, which is the reciprocal of this. So cos theta is 1 upon 1.5. Cos theta is straightforward 1 divided by 1.5. So I'll first solve this 1 divided by 1.5, which would come out to be 2 by 3, which would be straightforward equal to 0.666 or let's say 0.67 after rounding it off. So now I have to simply find the cos inverse of this. So we were given secant theta, so I first converted it to cos theta because my calculators only allows me to find the angle if I know the cos, sine or tan. So this is the task. So even in the next question which you are going to do, I would be giving you a term which would be let's say related to secant theta, cosecant theta or cot theta. And from there you have to find the angle using the same understanding. So if cos theta is now 0.67, so now we can find the cos inverse of this term, which is the cos inverse of 0.67, and that is equal to 47.93 degrees. So theta in this case would be 47.93 degrees. So this is the sense which I wanted to discuss using the same understanding. So now apply the same sense in the next question completely by yourself. So this was the term. So in a single question actually I have given you two questions. So cosecant A was 1.8. So cosecant A, we clearly know that this is the reciprocal of sine A. So it means sine A is known to me. Sine A is 1 upon 1.8. So this was the task. So my task was to first simplify, first find the value of sine A so that I can ultimately find the value of this angle A. So sine A is the reciprocal of this cosecant A, which is 1 divided by 1.8. So this 1 divided by 1.8 gives me value as 0.555. So 0.55. So I have to find now the angle theta corresponding, I have to find this angle A which corresponds to sine A as 0.55. So now I am simply using the sine inverse function, for which I have to find the sine inverse of 0.55, which gives me the value as 33.36. So this would be my answer, 33.36 degrees for this angle A. So now comes the task of this secant B. So secant B is given to me as 2.5. So we know that it means cos B, which is the reciprocal of secant B, would be 1 upon 2.5. So 1 upon 2.5 we can simplify, that would give us simply, so 1 divided by 2.5 would give me 0.4. So cos B is 0.4. So B would be the cos inverse of 0.4. So we can find the cos inverse again using the calculator. So second function of cos inverse 0.4 gives me the answer as 66.42 degrees. So this would be equal to 66.42 degrees. This is my answer. So the purpose was to make you understand this basic sense that there is a possibility that we would be given angles in terms of cosecant, secant or cot. So in order to actually find those angles, we would be required to actually first convert them to their corresponding ratios which are available on our calculator. So this is the first task. So now these were like the basic understandings. We have in today's class, we have just understood 3 new names which are very straightforward. So the basic task is actually to solve the triangle, and that is the ultimate task which we would be doing, let's say in today's class as well, and even this would be continuing in the next class. So now the main task is this, that let's say we are given a triangle, and these are the kind of questions that we are going to deal from this moment onwards. So let's say in our triangle, any 2 terms would be given to us, and we would be required. So just by actually getting any 2-3 terms which would be given to us, we can solve the entire triangle just on the basis of that. So this is the task now. From this moment onward, this would be the main task. So I'll just start showing you the main understanding. So let's say this is a right angle triangle, and let's say I'm given any side. Let's say this side is 5, and this angle is given to me as, let's say, just for the sake of example, I'm taking this angle as, let's say, 50 degrees. So if in a right angle triangle, one side and one angle is given to me, so then we can crack this entire triangle just based upon this understanding. So this is the interesting part. So let's say if I have to find this hypotenuse, only one side is given to me. This angle is 90 degrees. This is given to me as 50 degrees. So since this is a right angle triangle, can we see that the third angle is directly known to us as well? So this is 90, this is 50, which comes out to be 140. So the sum of all these 3 angles in a right angle triangle, in fact in any triangle, is actually 180 degrees. So the remaining angle would be 180 minus this 140, which gives me 40 degrees. So first of all, now I know this angle. This is the first step. So after actually knowing this angle, can we now see that with the help of my trigonometric ratios, I can solve this entire triangle now. So let's say if I name this side as H, and let's name the base as B. So if I have to find this H, so now we know the trigonometric ratio that 5 upon H is equal to sine 50 degrees. 5 upon H is equal to sine 50 degrees. So we have created an equation through which we can easily find the value of this H. So H would be what? Straightforward, it would be 5 divided by sine 50 degree. So now this is the task. So now I can simply solve the value of this expression using my calculator. So the task is now to find the value of sine 50 degrees. So it would be sine 50 degrees, which gives me the answer as 0.766. So I have to take the reciprocal of this value now. So I have to take the reciprocal of this value. So it would be, my answer would be 1 divided by 0.766, which gives me the answer as 1.305. So it would be 5 multiplying with 1.305. So if I multiply this by 5, my answer would be 6.52. So just taking the first place of decimal only, it would be 6.5. So the hypotenuse would be 6.5. So just notice from the place where we started, we were only given this side and this angle. And now we have obtained this side H. The hypotenuse is known to me. So now I can find the base either by using the Pythagoras theorem, or I can simply use my trigonometric ratios as well. So using the same logic, can we see that this 5 upon base stands for perpendicular upon base, which in this case is actually now tan 50 degrees. Which means that this B is equal to 5 divided by tan 50 degree. This is the sense. So now again my task is to find the value of tan 50 degree, which is tan 50 degree, that is equal to 1.191. So now I have to find the reciprocal of that this is 5 divided by 1.191. So I have to find 5 divided by 1.191, which gives me the answer as 4.198. 4.198. So I'm just rounding that off. It would be 4.2. So this side would be 4.2. We have solved this entire triangle now. Just on the basis of this side and this angle, we have solved all the remaining sides and the angles.